mathematical calculations are done using arithmetic operators in C. So we know the formula to find parallel equivalent of resistance. If there are two resistors, then we know that it is 1 upon Rp equal to 1 upon R1 plus 1 upon R2. If 3 resistors, then 1 upon Rp is this value. If 4 resistors, then this value. So let us do it for 3 resistors. Then the formula gives us 1 upon Rp. So to find out Rp, we have to get the inverse of this. So Rp is equal to 1 divided by this 1 upon R1 plus 1 upon R2 plus 1 upon R3. So let's use this. So here, the values of resistors could be anything. So let's define them as a float. So float, let us say R1, R2, R3. Suppose if we are doing for 3 resistors, and the answer is Rp. Then we have to read these values. So tell the user that to enter 3 resistors in say ohms or kilo ohms, whatever that we want, we should give that message. Now we have to scan them. So %f because they are floating, %f, and we are reading the 3 input values R1, R2 and R3. So the 3 values we want to read. Now we know that we have to write down that and is the address. So let's put that. After that, we have to calculate the value. So Rp is equal to 1 divided by, now there will be a bracket, within the bracket 1 slash R1, now plus, after that we have to do plus 1 slash R2, again plus 1 slash R3. Now we have to print the answer. Printf parallel equivalent resistor is equal to, we have to print it, so %f, and we will print the value of Rp. That's all is the program. Now let's run this program. So run, enter 3 resistances ohm. I just take any 3 values, suppose 10, maybe 15, maybe 20 values I enter. Parallel equivalent resistance is this. So in this way we get the answer. We can run it again for other any values. Suppose the 3 resistances are say 120, suppose 200, maybe 500. You get, what happened to this, 120, 300, 3000, 300, 500. Run this, something happened to this. Enter 3 resistance, 100, 400, 500, parallel equivalent resistance is this. Something happens to the internet, I don't know. So in this way it works. Now let's go to another formula. Formula to find out frequency of Wien bridge oscillator is this. Frequency is equal to 1 divided by 2 pi RC. So this is actually, we can have bracket here because everything is in the denominator. So its C statement will be 1 slash 2 star pi star R star C. So we can give the value of pi, or you can write down 3.14 as a pi. Similarly, to find out frequency of a stable multivibrator using IC 555, the frequency is this. value 1.44 RA plus RB into C. So in any of these, to find out frequency, we have to provide the values of RA, RB, C here and R and C here. So let's do one of them here on online compiler. So we will have here, suppose we are finding the frequency of 555. Then RA, RB, comma C is the capacitor. And we will find out frequency F. Now we have to enter, we have to give a message here that enter two resistors and one capacitor. This capacitor, we know that the capacitor's values are in nanofarad, picofarad, microfarad. So in what range we want the value that we can give. So that user will enter the value in this way. It is for the convenience of the user. So suppose we want in microfarad, then it should be in microfarad. Okay. So this way we will do this. Now we have to scan all the three values. So here we have to give RA, RB and the value of C. We have to give and the value of C. And we have to find out now the frequency. So frequency is equal to, I just slightly expand this, frequency is equal to 1 divided by, now value, one more, RA plus RB. The spaces are actually not necessary. It is for our convenience. Star C. So star C. Now this is the general formula. But we are considering here that we want the capacitor in microfarad. So we must consider that factor here. Microfarad is 10 raised to 6. 10 raised to minus 6. It is in the denominator. So in the numerator, it will be 10 raised to plus 6. So it should be 1 star. We should write microfarad for that. 1, 0, 0. One more 0. This is 1K, 10K, 100K and 1. So for microfarad, we are compensating this. Now we will be writing here as frequency is equal to, and here we will write on F. Frequency will be displayed here. All are in float. So we have to enter the resistances in ohms, but capacitor in microfarad. Let's hope it runs properly. Two resistors. So I just enter some two resistors. Suppose 10K I want to enter, then I must enter that 10,000. Suppose another resistance I want 5,000, then 5,000. And capacitor suppose 0.1 microfarad, then 0.1 microfarad. What is happening here? Some internet problem, I think. 10,000, 5,000, 0.1 microfarad. Enter. Just wait. Yes. The frequency is 666.66, whatever it is in hertz. So in this way we have calculated this frequency. Now we can write down formulae for Wien bridge and find out the frequency for that. Now we know that we can convert the binary to gray and gray to binary. These are the equations for binary to gray conversion, where grays are the outputs and binaries are the inputs. Similar equations you already know for gray to binary. If we want to define this, gray and binary are the bits. So actually we can use bool also. But bool is not supported by this online compiler. This is one thing. And though bool is there, actually in memory, bool is not stored as a single bit, but it is stored as a character. So 0 means 0, 0, 0, 0, 0, 0, 0, 0. So 8 zeros. And 1 means 0, 0, 0, 0, 0, 0, 0, 1. That is 0, 1. In this way it is stored. So we can use that in the character form. So we can write a program. Many versatile programs can be written here for any number of bits or we will write here the program for 4 bits, and assuming that the user will actually enter the binary and will not do any mischief by entering other values also. So let's define that unsigned character. It could be unsigned character or signed character, anything. So we have to define all the inputs and outputs. So B3, B2, B1, B0 are there, and G3, G2, G1 and G0. All these are the values of inputs and outputs. Now let's come to the formula. G3 is directly B3. G2 is equal to B3 XOR B2. G2 is G1 is B2 XOR B1 and G0 is B1 XOR B0. So let's use this formula here. So we have to first read B3, B2, B1, B0 from the user. So printf enter 4-bit binary. This is the measure for the user, message for the user, and then we will scanf. Here we are reading 4 bits, so %. But these bits we are using as a numbers only. So %d, 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 %d. So 4 bits we are reading, and for that and B3 and B2 and B1 and B0. So in this way 4 bits we are going to read. Now we will generate the outputs. G3 is equal to B3. Very simple. G2 is equal to B3 XOR. Now this is the symbol for XOR. B2. Next, G1 is equal to B2 XOR B1, and G0 is equal to B1 XOR B0. All these are the statements. That's all. And now we have to display all of them. So we have to write the print statement. So I just reduce the expansion. So printf, we have to print the number in gray, binary to gray. Yes, gray is equal to gray code is. We will print here G3, G2, G1 and G0. This we have to print here. Now to print them sequentially, we should write here %d, 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 %d. So they will be printed now. Okay. Now let's run this program. Run. Enter 4-bit binary number. So I just enter some number 1. We have to enter the separate digits because we are considering every digit as a separate. So 1001, its code is 1101. Let's run one more time. And by writing the opposite program of gray to binary, we can always compare. Suppose this is 1, 0, 1, 1 suppose. This is gray code. we can compare this using that. Let's write one more program. In case of digital circuits, we need to draw the truth tables of the circuits. So circuit may have many inputs, 1, 2, 3, 4 inputs. Let's our circuit has 4 inputs. Okay, let's our circuit has 4 inputs. We can define those inputs, though they are in Boolean. I told you that define them as a character A, B, C, D. And the output is suppose Y. And the output is suppose Y. All are connected. Now there could be any relationship between A, B, C, D. Suppose A or B and it is ANDed with C and it is exclusive OR with D. Any relation it could be. And we have to draw the truth table. Now in the truth table, we have to write down the relationship and we have to consider the values of ABCD. Every value of ABCD could be 0 or 1. Okay. And we have to put the heading also. So let's put first the heading that we have to display all of them A, B, C, D and Y. So let's display this. Suppose A, then I just keep one space. Then for good looking, let's use capital A. In one space, 1 or 2 space, whatever is required to us, 2 spaces, suppose B. Then C, we have to remember whatever spaces we have put, exactly same spaces we have to put at here. I will put 3 spaces Y at the outputs while writing the outputs, otherwise there will be a mismatch. And then the remaining truth table has to be put in from this next line, so backslash N. So this will be the title. Now we have to consider each condition, each variable going from 0 to 1. So we need 4 for loops for A equal to 0 to A less than 2, because 0 and 1 only 2 values are there, and A plus plus. This is first. Okay. So there will be a curly bracket here. Now next for loop will start for B equal to 0 to B less than 2, B plus plus. Now here one more loop will start. So I just put just for understanding this way. So next is for C equal to 0, because C also can change the value between 0 and 1, C plus plus, and then one more for D. I just put this way so that we understand that this next is going on. For D equal to 0 to D less than 2, D plus plus. And then the main for loop will start. So these are all 4 conditions. Now we have to write down the relationship. The relationship could be anything. Suppose Y is equal to A and B, and suppose it is OR with C, suppose exclusive OR. You can have any exclusive OR with T. This is the relationship. Okay, these are the logical operators and or etc. And we have to print the values of all. So printf, we have to print all the values. So printf %d 2 spaces, %d 2 spaces, %d 2 spaces, %d 3 spaces, just for look good, %d. So 5 values we are going to print: A, B, C, D and Y. So A, comma B, comma C, comma D and Y. Okay. These 2 things are done. So 1, 2, 3, 4. So 4 curly brackets will end here. 1, 2, 3, 4. 1, 2, 3, 4. So it will go this way. So it will look this way. Now let's run this. Run. Oh, here we should put \n because one line is over. Run. Good. A, B, C, D and Y. Now this is for this relationship. Observe this. Check whether it is correct or not. If you want any other relationship, suppose you want XOR here, you want OR here, OR, this output will be different. Run. A, B, C, D, Y. So the truth table of any logical relationship we could get in this simple way.